Hello, everybody. My name's Clifford, and I'm a solutions architect at AWS. For today's workshop, I'll do a little bit of an introduction on AWS, the services that we have that can help with your machine learning use cases, as well as we're going to do a hands-on workshop for people who are in person today. So without further ado, let's get started. So, as many of you already know, the ML reach in the world, around the world, is growing rapidly, and it's encompassing many different categories, including automotive manufacturing, where you have predictive maintenance, financial services, where you have fraud detection, retail, where you have demand forecasting, and so on. There's a lot of areas where machine learning can benefit. However, the machine learning development is complex and costly. For data scientists, you have to pick your algorithm, you have to label your data, train your model, collect and prepare your data, tune your parameters, store features, then once you've done all that, deploy to production. There's a lot of different areas that poses different challenges to data scientists. So let's quickly go over the machine learning process. So you start off with the business problem. So, sales problem or marketing problem, things like that. But from there, you have to be able to frame it into a machine learning problem. Not all business problems can be solved by machine learning. Afterwards, you're going to have to start collecting your data. They may be in different silos. They may be in different areas, different formats. You have to start integrating them together. And you have to start preparing and cleaning the data. There might be some legacy reasons the data isn't formatted correctly. You have to do a lot of those steps. Once you're done with that, you can then start visualizing your data to detect for outliers, things like that. Then you can do some feature engineering. Only then can you start doing your model training and your hyperparameter tuning. And then after that, you start evaluating your model against possibly offline or historical data or real-life data. Then you have the question, has your business goals been met? This is a key point. A lot of times I've had customers who always try to strive for lowest or the highest accuracy, things like that. But we always tend to forget that this is to solve a business problem. So we frame it back, does it solve the business goal? If it doesn't, you might have to go back and collect even more data. You might have to do the entire process again. If you do have enough data, and maybe it's a feature engineering issue, then you go back to visualize your data, see if there's anything else you can change or tune. Once you're done with that, let's say we're complete and the business goals are met. Then you have to deploy it. So you have to then take this model and then deploy it on a server that can scale, that can handle requests, and then you can start doing predictions. But that's not the end of the story. You still have to monitor, potentially debug your models. And because over time, you'll have things like model drifting, performance, real life situation changes, your model performance might drop. So after a while you're monitoring that, you might end up having to do some retraining, and you start this entire cycle again. So we break these up into different categories. You have the discovery phase, where the analysts tend to be the ones that handle this. They're the ones that understand the business, they have business knowledge, they have the domain knowledge, they understand the business objectives, they understand the context surrounding all the data. So they can help facilitate what is a machine learning problem. Then you have the integration stage. So this is where data architects, solutions architects comes in, and this is where you start having to build a data platform. Now on AWS we have a few different services, but for today I'm not going to go too in depth. We have things you can do, things like lake formation to build out your data lake easily. You can use Glue to run your ETL jobs, Athena for querying, QuickSight for BI analysis. Of course, SageMaker is also part of that. And then the middle part is the main portion, or I would say what most people see as the main portion of machine learning. And this is where Amazon SageMaker comes in, where essentially you do all the model training, all the hyperparameter tuning, and this is where we have a bunch of different services I'll go into a bit more detail later. And then finally, the hosting portion, which of course you can use SageMaker to host, but there's also, it's not the only answer. There's also different ways. We have customers that host the models on our serverless offering, Lambda, or build it into step functions for asynchronous invocation, things like that. So after I talked about that, you might ask, why would we use AWS for machine learning? Well, at AWS, we have the broadest and deepest set of AI and ML services, launching over 200 new features and services this last year alone. So we have solutions at every layer, every skill level, no matter if you're a data scientist with many years of experience or you're just starting to learn machine learning. We'll later touch on SageMaker, which is a single IDE for the entire machine learning flow. And there are a lot of cost-saving benefits to leveraging the cloud when running your training jobs or hosting jobs. So before I go further, I talked about how we have the broadest and deepest services. This is how we describe it. We describe it by the ML stack, where we have 3 different layers of our machine learning offerings. At the lowest layer, you have the raw power, the instances, the framework supports, where we support TensorFlow, PyTorch, Apache MXNet out of the box. We have some deep learning AMIs that I will cover later, containers. We have some GPU instances for you to run deep learning training. We also have our own chipset called Inferentia to help you run inferences in the cloud, and also elastic GPUs that you can attach to any instance. Then you move up a layer. You have SageMaker, which is a managed service for pretty much almost the entire ML flow use case, from labeling your data all the way to deploying your data. And then for customers who might not have enough time to develop, or they don't have the data science knowledge to set up, we also have our AI services, which are managed services that you can call for machine learning use cases via API. Some services will train a model based on your data. Some of it is already pre-trained. So for example, like recognition, our vision service, you only need to call an API, pass in an image, and it will return the information back. Things like personalized, where it's our recommendation engine, you can feed your own data in to generate with our algorithms to generate a model specifically for your use case. So what is SageMaker? To put it simply, Amazon SageMaker is a managed service that helps you manage end-to-end ML flow, essentially. At the root of it is our SageMaker Studio, which is our web-based IDE, and everything can be done from that. It's a fully managed service where you don't need to manage the infrastructure. You just need to spin up a notebook and then start developing your models. Then you can deploy it using SageMaker as well. Some of the benefits of SageMaker include accelerated ML development, because we have many different tools. Based on our customers' feedback, we have lots of different tools to fit different use cases or different needs or different portions of that ML lifecycle. By using all these managed services, you can also boost the data scientists' productivity. And of course, reducing cost is very important to us. So a lot of these will have cost-saving measures, be it using spot instances or savings plans and such. So here's a high-level view of Amazon SageMaker. You'll see that we, from end to end, from preparing your data, preparing your model, building your model, training and tuning your model, and deploying and managing your model, we have many different services and different capabilities, I would say, that help facilitate different use cases. All of this is under our SageMaker Studio IDE. So for today, we'll be using SageMaker Studio notebooks to build a model. And because this is a part of the competition is to have your own model files and put it into a container, we'll also go with the concept of bringing your own models. Of course, SageMaker has a lot of built-in algorithms that you can use and deploy to AWS. But for today's workshop, we'll be bringing your own models. So for the sake of time today, I skipped a little bit of the data preparation and the stage, but again, we have different services. If you have any questions, feel free to raise your hand, and we can have a little bit of a Q&A as well, if anyone has any questions. So I'm going to jump straight into the training portion of SageMaker, the core of today's exercise. So in SageMaker, we have 3 different ways, or 5 different ways, I guess. Three main ways of building a model. The first of which is using our built-in algorithms. So we have 17 different built-in algorithms for different use cases that you can just feed in your code, and it will generate a model for you. Now, some people might need more flexibility. So they might be using a framework such as TensorFlow, MXNet, PyTorch, and want to build off that. So we also support some containers that already have these frameworks built in. And so all you need to do is bring your training script. So this is where we talk about bringing your own script. But finally, sometimes some data scientists might have their own framework they use or build something completely from scratch, and they need full control of the training lifecycle. So from there, we also offer bring your own container, where you build your own container to your specification, and we'll take that and use that for training. Now, of course, there are other ways. You can, of course, go to our AWS marketplace, where our partners may have some algorithms or some pre-built models for you, or SageMaker Autopilot, which helps you if you don't really know how to do feature engineering or what model to pick. You can use Autopilot to automatically do those steps for you. So just now I said you can bring your own container, and some of you might be asking, why? So with what we found out, what happened in the machine learning community is that we found that it's really difficult with all these different dependencies to manage multiple different environments or create a reusable environment. Maybe I train in my environment, you train in your environment. It's very similar to developer life cycles where dependency issues, things like that. So, as with development, containers are perfect for machine learning because they're lightweight, they're portable, they're scalable, and they're consistent. So you can package all your dependencies into a container image, put your own training script in there, and have, no matter on what environment, you can have the same repeated outcomes. So how does that happen on AWS? Well, we have a service called ECR, Elastic Container Registry, which is our container registry service. So you might be building your container, and then you want to share it with someone else. You'll then push it into ECR. And then when someone else needs to use it, with the right permissions, of course, they can pull that and have the exact same setup as yours when it runs training. This is where the repeatability comes in. And so with that, we created our deep learning containers, which are prepackaged container images that are fully configured and validated for different ML frameworks. They're optimized with the latest NVIDIA drivers, the CUDA libraries, Intel libraries. They're lightweight, and they're optimized for distributed machine learning, meaning multiple instances running collaboratively to build a model. And of course, these can run on our container services, such as ECS, EKS, but also on SageMaker. Of course, we have a decent-sized list of which containers we have, so I'm not going to go too in-depth. Essentially, popular frameworks, TensorFlow, MXNet, PyTorch. We have GPU optimized, CPU optimized, things like that, all in here. There's a link to the repositories, all in here. And so what people tend to use, how people tend to use this in AWS is essentially loading the deep learning AMI onto a GPU instance. The GPU instance is then backed by our Elastic Block Store so that there's persistent storage in there. And the deep learning containers are pulled from ECR. This allows for collaborative development, collaborating in code, aligning in code and dependencies. Also allows you to scale and easily manage infrastructure. So on AWS, this is where the lowest level all the compute resides. No matter what service you're using, behind the scenes, there's no magic. They're all instances. So under the scenes, there's our EC2 instances where the containers will run. Now, if you want to manage these containers, you can always use services such as our Elastic Container Service, ECS, or Elastic Kubernetes Service, EKS, or on top of that, a lot of data scientists enjoy using Kubeflow as well. And all these will pull from the image registry. And then for people who want a more managed service, who don't want to deal with the hassle of building and maintaining all of this, there's SageMaker on top, which will help manage all of this. Let's say just hosting, you just define where your image is, we'll take that, do the training. I'll go into that in detail. So now let's quickly move on to when you bring your own script or bring your own container. How does that work in SageMaker in our managed training? So when you start developing, either on your laptop or in the cloud, you use our Amazon SageMaker SDK, which is a high-level SDK that essentially abstracts away from the entire process. As you can see in this example, I am creating a new estimator with TensorFlow. So defining, telling it to use TensorFlow's, our managed TensorFlow deep learning AMI. We're telling it where our training script is located, what role we need to use, because in the cloud, everything is, you don't have permission by default. Even our services don't have permission by default. So you need to give it a particular role. So you have to give it permission to access your data, essentially. Then you tell it what framework, what instances, how many instances you want, and what instance size. In this example, P3X large is our GPU instance. You then take your code files, and then, well, we take your code file. When you call that, when you call fit, essentially, we take your code file, combine it with the deep learning container, and then deploy it into Amazon's fully managed SageMaker cluster, which will then run its training job. It will pull the data your training data from S3, do all its training, and when it's done, write out your model back into S3, and then shut down the instances. So all you need to do with bringing your own script is point to the AWS managed container of your choice. You write your model as a bundle of files, including any dependencies. Let's say your Python script has other things you need. You add a requirements.txt, things like that. Specify your entry point, which is the Bootstrap script. Include all your extra libraries in your requirements.txt. And when you're done with that, you can use our servers for inference as well. So this is, oops, sorry. Essentially, this is how a high-level picture looks like. ECR, we have different images, such as scikit, TensorFlow. You call TensorFlow, I already said this. One of the key points is the estimator.fit part. When you call fit, that's where it triggers the training job. You pass it all the training parameters, such as where your files are located. We'll go through this in the training later. And then this is where it all pulls it up into one instance, trains it, and completes. Now, when you bring your own script, there are some things that you have to be aware of. So some changes that you need to do. You need to add, for this example, this one's PyTorch. But you need to, I believe this is a PyTorch example. Anyway, what you need to do is you need to add parameters, environment variables, basically. So SageMaker will then pass environment variables into the container when it calls the run training job. And so this is how you extract the information. So this is where you might have your hyperparameters, your output location, where your model directory is. And you can see on the right-hand side over here, this is where our environment variables are passed in. So you need to parse those environment variables for you to use in your training script. So, yeah, so essentially, you upload your data to S3 when you're ready to do your training. We spin up a training instance. We copy your training data and your validation data into the instance's EBS volume. We then call Elastic Container Registry and pull the correct image that you specified. So, for example, PyTorch. You pull that. We pull that in to the instance, spins it up, and then we take our SageMaker training toolkit, which is embedded into our deep learning AMI that does all these Bootstrap setups. It will then configure all the setup where the model directory is. It will help copy the model, for example, your model directory, your data files. It will all parse that and set that up for you. So it will map that environment variables essentially into your directory locations. So there's a folder structure in our documentation space that defines where we put different things inside the Docker container. Then we copy the training script that you specified. The script is called, hyperparameters are loaded, and you can kick off your training. So it reads all that, and it reads from the environment variable. And then once it's done training, it'll output it back into the EBS volume. And before before the instance is terminated, we copy it back into the S3 bucket, your storage bucket that you specified. Now the process for scripts and containers are very similar. I'll go through it in a high level, and then we can skip over a little bit. Instead of just uploading your script, you build your Docker container. So you add your Docker file, all the dependencies, how it's built. You build it, and you deploy it, or you push it into the container registry. And so when you call an estimator, you use our default estimator, and you pass it the training image location. So in ECR, you'll have a path, a URL. You define that in the estimator, and it will pull that and do your training job. Simple enough, that's essentially how that works. And the same process as write your script, or bring your own script. So the benefit of this is you can write your own model however you please. You can use whatever framework you want. It's not tied into any of our supported deep learning AMI. You point your model, you put your model into, put it into a Docker file, upload it to ECR, point to the container's address when you run your training job. And you also have to implement there are some extra implementations that you need to do, such as serve, which is how it calls the function. So that is, in essence, how it's done. So in high level, there's more information in our documentation if you want to have a look. Basically, when you bring your own container, we have pre-configured file paths, such as everything's in opt/ml folder. Then we have places, your training code goes into the code directory. Any outputs will be placed in the output directory. Your model will then be written to the model folder, and any inputs such as your hyperparameters and your data will be written into the input channel. So maybe we can do a bit of a Q&A if anyone has any questions so far. If not, we can go ahead and move on to the hands-on portion of the workshop. Anyone with a question can raise your hand. Can someone...
Okay, thank you very much. Say, if I want to use my own code editor, like VS Code, to develop my scripts, is there any way to interface with AWS via VS Code?
Yes, you don't need to use our cloud IDE if you don't want to. So as I said earlier, we have the Sagemaker SDK. That's just a Python library. And you can use the Python library locally as well. You just have to configure your AWS credentials on your computer. So if you download and install our AWS CLI, you can then do configuration, AWS configure. You can then put in when you create an account on AWS, you'll have some access key credentials. That allows you for programmatic access. You'll have an access key and a private key. You put that into a folder in your user directory.aws. Credentials live there. Those are where the SDK will look for. When you run your script locally, it will then look for that credential file. And then you can call SageMaker SDK, do everything the same as in the cloud. So you can do that locally as well.
So I can set up the SSH instance to connect to the AWS service via SSH?
Oh, you don't need to do SSH at all. Okay. This is fully through the SageMaker. We have an API interface for you to connect. Some people might want to do some deep learning directly on an instance. You can, of course, spin up a GPU instance and SSH on that. However, that can be costly because running GPU instances for a long time is more costly than when you need it. With SageMaker, I showed earlier when I call the .fit function, when I call for a SageMaker job, I'm actually calling the SageMaker API, telling it to run a training job with my data set. And what that does is that SageMaker then spins up some instances when I need it, runs the training job, then shuts it down. So the cost is only the lifetime of that training job, down to the second. So that way you only need to call, you don't need to have this GPU instance running all the time for you to test out your training jobs. And you can also leverage the elasticity of the cloud. So let's say I run 10 training jobs. Behind the scenes, that might be 10 different instances. So I can run them in parallel, and I'm only charged for the time that those 10 instances were running.
Thank you very much.
Does anyone else have any questions? If not, we can do some hands-on. I'll go a bit more in depth during the hands-on portion because I want everybody to get some hands-on experience. And apologies to the people online. The hands-on portion, I'll go through the code as well, but the hands-on lab portion will be available for the people in person. So without further ado, let's start our workshop. So to get started, please go to this website that's not on. There we go. All right, so please go to this website, dashboard.eventengine.run. This is how we provide some free accounts for everybody, or sandbox accounts for everybody to try. When you enter, sorry, what? Yes. Unfortunately, for the people online, I'm currently showing the URL that's for the people in person. Later on, we'll share my screen, and I'll go through the workshop with everybody else. So if you, before we start, sorry, I would like to quickly introduce the helpers we have today, solutions architects. We have Akil, Ming over there, and Hey over here. So all three are solutions architects. If you need any help, just raise your hand, and someone will come and help you. So please go to dashboard.eventengine.run. When you go there, you'll be presented a box to fill in. Please enter the event hash 5A61, blah, blah, blah. And then when you fill that in, you'll be prompted to do a one-time password login. That's how we map a user to the account. So please fill in an email address that can receive an email. It doesn't have to be work email or anything, just an email address that can receive an email address, or receive an email. We'll send you a one-time passcode, and then once you enter the one-time passcode, you'll be logged into the account. I'll run around a little bit just to quickly check if everybody's okay. Is everybody inside? Wow, that was fast. Everybody's really quick. Cool, okay. Let me quickly show my screen. Sorry, 1 second. Okay. So once everybody's in, you should see this screen. When you want to log in, you press the AWS console. This should pop up a login link. So when you click on this, open console, you should jump into an AWS console. Now for today's workshop, we'll be in the Singapore region, so make sure on the top right-hand area, you are in Singapore whenever you're doing something. So we're going to go to SageMaker. And we're going to open up, or you can search for SageMaker here if you don't know, if you don't have that there. So search for SageMaker, open that. You should get to this page. Once you get to this page, open up SageMaker Studio. Now, we already pre-created a domain for you. In your own account, you will have to set up these defaults for the Studio domain. This is what everything runs off of. So the domain will have, I said earlier, you need to pass a role. So you have to have an execution role. This is a role that passes on to SageMaker, giving it permission to do things like access your S3 buckets, allows you to run training jobs, things like that, or access your container registry. So from here, we already pre-created a SageMaker user for you. So all you need to do is click here and launch Studio. You might want to open this in a new tab because we'll be using the console a bit later. So when you open that, it'll be redirecting you to our SageMaker Studio. I'll share my screen now. That's on. Sure. All right. If everybody's opened up to SageMaker Studio, so this is SageMaker Studio. You'll see that it looks very familiar to Jupyter Lab. It's based on Jupyter Lab, so you have a lot of the benefits of Jupyter Lab, but also fit for a lot of customizations for cloud. So next up, we'll need to download our project, our project codes. So if everybody can see this. All right, so we're going to be downloading our lab from here. So it's a bit.ly shortened URL, AWS_gluonTS_lab. So everybody download that to your desktop, and then we'll upload it to SageMaker. So enter this URL into your browser, and then we'll download the repository, or we'll download the project code. Has everybody downloaded the link? You should have a zip file, I think, labeled Global AI Challenge Lab. All right? All right, so if everybody's okay, we're moving on. So once we've done that, we should have a zip file, Global AI Challenge Lab. Let me just okay. So we're going to just drag and drop our Global AI Challenge zip up there. Once we've uploaded it, we need to unzip it, but that doesn't have automatic unzipping capabilities, so what we need to do is launch, let me zoom in for everybody. Okay, so what we need to do is launch a new terminal. So when we launch a new terminal, you should see bash shell script, because behind the scenes, this is also an EC2 instance, so you can run Linux scripts. So we're going to install Unzip, sudo yum install unzip -y. Once that's installed, remember it's sudo yum install unzip. Once that's installed, we can unzip our folder. So you can type unzip global AI challenge. And here you'll see that it unpackages everything. If anybody's having trouble, please raise your hand. We'll have someone run over and help. So once this is installed, once this is unzipped, we can start by opening. You'll see 3 different files. You can ignore the zip. There's our lab, which is a Jupyter notebook. We have our lab entry point folder, which is where our training script is and the requirements that we need, and an image for inside the Jupyter notebook. So if we open this, once we open this, we need to specify a kernel to run. So behind the scenes, Jupyter has a bunch of different, as I said earlier, deep learning AMIs behind the scenes. So to run this notebook, we'll need to select a new kernel. So in here, you'll see a no kernel. We'll click on this. Now, by default, a lot of people will use data science. That comes with things like NumPy, Pandas, some of the default Python packages that you will use already pre-installed. However, for today's workshop, we're going to be using MXNet, so deep learning framework, and we're going to be using 1.6. So please select the MXNet 1.6 Python 3.6 CPU optimized deep learning AMI. So we're going to be selecting that. Select this. Now it'll take a little bit for the kernel to start. What happens behind the scenes is it's downloading the kernel, deploying it on an instance that we define. Once it's deployed into an instance, then it will connect to the SageMaker Studio. Will connect to that instance to send commands to. Now, for the sake of time, I've already set this up on one of my other accounts. So now you should see here when you've set it up. Once you've set it up, it should show you that you have an instance with 4 CPUs, 16 gigs of RAM, potentially sometimes a GPU, depends on what you select, but make sure you select the MXNet 1.6 Python 3 CPU optimized. So what this does, in this deep learning AMI, it already has MXNet built in, installed. All the dependencies are in there already, so you don't necessarily need to reinstall it when you're running it. Is everyone okay so far? Can I get a thumbs up? Anyone? Everyone? Good? Good? Feel free to raise your hand if you're stuck on any part. We'll come over. All right, I'll give everybody some time to set it up. Dashboard.event engine .event engine. Remove the log. .log in. Hold on one second. Let me grab a hash. Is anyone else having any issues? Okay. All right, has everybody loaded up the script? Loaded up the kernel? Oh, file, go to file, new, you open a new terminal. New terminal. Yes. And then sudo yum install. Sudo, sudo, space, yum, yum. Install, unzip. So this is installing the dependency to be able to unzip the folder. Once that's done, you can just type unzip. Tab 都得嘅，撳 tab auto complete press tab there you go there you go now you open this one double click it yep and then click the kernel click on data science select this one yes and then select done now it's loading up no problem. Everybody else okay? All right, if everybody's okay, let's continue. All right, so if everybody, okay, so we're back to the studio interface. So once we've opened this, once you've made sure that your kernel has started, we're going to be running this workshop. Remember, this notebook has some things you have to modify or add. So what we're going to be using today is Gluon. Gluon is a toolkit for MXNet to help write better or easily write deep learning models. And so Gluon, we have a Gluon time series toolkit, which helps use essentially build deep learning forecasting models. So today's workshop, we're going to be doing a forecasting model using Gluon TS, which behind the scenes leverages our deep AR algorithm, which is our deep learning forecasting model using recurrent neural networks. So if you feel free to read a little bit more information about our deep AR algorithm, if you want to understand how it works behind the scenes. If not, we'll move on to the next step, which is, first of all, we need to install our dependencies. This is the same as any Jupyter notebook. We're going to have to install our dependencies. So we're first going to install our Gluon TS package, as well as upgrading our SageMaker SDK. So you'll see that it's finished installing. It'll output a bunch of different information about what's installing. Once we've done that, we can then import the dependencies that we need. So we're going to import our Gluon TS. Gluon TS also comes with some built-in data sets for training purposes. So we're going to import the repository with the data sets. We're going to import our models for local running, as well as import MXNet. So we're going to import all these dependencies. You might get an error like this. Don't worry about it. It's just recommending using another module, but it still works. So what we're going to do next is load up our built-in Gluon TS dataset. So we're going to check what datasets we have. So above, we imported a function called dataset recipes. We can list them out. So these are all the keys of the dataset. So you can see there's a lot of different sample datasets, exchange rates, taxi information, some stuff from Kaggle, web traffic, solar energy. Today we're going to be doing electricity. So in the Gluon TS dataset, there are 3 different objects. So you'll have your training dataset, your test dataset, and metadata for information about the time series. In real-world use cases, you won't have it this nice. You will need to do it yourself. You'll need to take your dataset, split it up, 70-30, something like that, into training dataset and validation dataset. But for the purpose of this workshop, we're using one that's already been done for us. So what we're going to do is we're going to pull our electricity dataset, and we're going to put it into a folder in our Jupyter Lab, or in our SageMaker Studio, Gluon TS _data. So this, what we do is we call get dataset. And so what it will do, if we set regenerate as false, it will look for if this data set exists already. If it doesn't exist, then it will regenerate it. So you can see it created a folder here, and it's now pulling the data. So this will take a few minutes. I'll let everybody catch up while we wait. Friendly reminder, if you're stuck or have any questions, just raise your hand. We'll come over and help. Everybody okay so far? Ooh, too big. Is this size okay for everybody? Sorry, someone said the screen size was a bit too small. Try and enlarge it. Okay. So while this is running, you'll see, similar to Jupyter notebooks, there's a star, it's running, it's processing. So you can see that it's writing it to the Gluon TS folder. So if you go in here, you can see there's an electricity folder. You can see the metadata training's been written. It's waiting to write, I think, validation or test. So we'll wait for that to finish. We can see that it's now writing from my side, it's already writing to test. And it's writing the metadata. So now that's completely finished, we can now that it's downloaded, we can explore our data set. So we move on to the next one. We're going to be using matplotlib to map out our data set. So we first import the dependency. We take our training data set and iterate on it. We take, because the time series has multiple items, we're going to take one of these and generate a graph on one time series. So we're going to compare that. For our training data set, we're going to only take the 48 hours of the training data, and then we're going to take 72 hours of the test data. So what we want to do is show you 48 hours is used for training, and then the last 24 hours is used to predict. So we're going to plot this out. When we plot this out, you'll see it generates a chart. So the chart you see on the left side is the training data set that we will feed into our model. And then on the right after the line is what we're going to use to validate the predictions. So we're going to try and see how close our forecast predictions match historical data. Now all this is historical data, so keep that in mind. Once we're done with that, we're going to upload our data set to S3. So S3 is our object storage, and all the SageMaker training jobs will pull from S3 data sources. So later on you'll see when we create a training job, we specify where we want it to pull the data. So we'll pass it a path, an S3 path, to pull the data from. So what we need to do is we need to import. Boto 3 is our Python, AWS Python SDK. SageMaker is, of course, our SageMaker SDK. So what we're going to do is we're going to create new variables. We're going to call SageMaker.session. What that does is that it takes the execution role of SageMaker, the one we saw earlier, the role that allows SageMaker to be able to read from your S3, read from your ECR, registry, be able to call a training job. And we're going to create a session token. So all you need to do is call this session. We're going to define, when you create a SageMaker domain and you open up a Jupyter Notebook, SageMaker automatically creates an S3 bucket for you. So SageMaker will have a default bucket for you. Now, of course, you can pass in your own bucket if you have your own S3 bucket that you want to use. But for this exercise, we're just going to be using the default bucket. So here we're going to be using the SageMaker session to grab the current region we're using, which is AP Southeast 1. We're going to pull the bucket. So we're going to look for the default bucket, grab that, and we're going to add a prefix. So you can think of that as a folder. So what we're doing here is now we're going to upload. We're setting up our S3 path. We're going to take our local files, the metadata, the train file, and the test file, and then we're going to upload it here. We're going to do the S3 bucket resource.object and upload the file to S3. So once we call that, what that does is that it takes the local folder here inside, the contents in here, and then uploads it to S3. Once that's done, we can check what's in S3. So here you can see that we're calling S3.objects.all. So we're grabbing all the objects inside S3. So you can see when I do that, I'll have 3 objects in here. Now, of course, if you want to see physically see it, or outside of command line, you can always go back to the console. In the console, you just go to S3. In S3, there should be two buckets that are created. One is to do with the SageMaker Studio, and one is regular SageMaker. So this will be in SageMaker here. So when we go into SageMaker AP Southeast, and then there's your account ID, essentially. When we go in there, you'll see that the folder was, the path was updated. So there's a prefix gluon_ts, which is essentially like a folder. We go in there, we'll have data. And inside data, you'll see the three files, well, the one file, metadata.json. And then if we go into the train, we have our training data and our test data. So all this is visible to you. It's not hidden behind the scenes. It's just stored in your own bucket that you have full control over. So we have these three objects that we just uploaded to S3 so that we can kick off training. Everyone okay so far? Any questions? Everyone okay? Cool. So, what we're going to do next is have a look at our training script inside the lab entry. So we can call pigmentize, which colorizes the gluon, the Python script. And you can see that there are some relevant code here. So we have our train function. We'll have our train function, evaluate function, and save train model functions that handle each. So train handles the training logic, evaluate does testing, and then save train model saves it, writes it, persists it onto disk. So you can see here, it's the same. You essentially can just open up this and you'll see it as well. But in here, we also pigmentize it. So you can see here, it's doing similar things as what we had in the Jupyter Notebook because these are what we need. So we need to pull up import mxnet, gluon_ts. We're going to be pulling the deep AR algorithm. So we're going to create we're going to import a deep AR estimator inside the training script. So we're going to pull the data set. Now this script also pulls public data set if it's not available, but because we're passing it in anyway, so if it's passing in anyway, then it will use the S3 path provided. And then when it calls trains, it basically, you can see, it looks for the environment variable that SageMaker passes it to it. So this is where the training data set is located. It will pass that as an environment variable. We have all these configurations, prediction lang, things like that. Setting up the device, is there a GPU or is it CPU based? Then we'll have a training function, deep AR estimator. So this is where it calls the deep AR estimator. This is essentially how you write your script. From there, you can run your train function. That's inside your script that you would normally do even if you're not in SageMaker. Let's say if you're in a local notebook, these are the steps you would do. But you pass it on to SageMaker to do it for you in a script. So some functions here include creating a graph of the predictions that it did. And then here's a key area. Once it's done, you can get it to serialize the model back out into a file. And so when it serializes that model, it puts it, you have to put it in this model directory, which SageMaker will then automatically extract back out and put it into S3. If you don't put it here, then the model will be lost when the job finishes training. So this is crucial. So this is essentially what is inside that training script. Feel free to have a look a bit more in depth if you would like. And then from here, we'll start setting up our SageMaker training to run this training script. So what we need to do is we need to define our configuration. So we will need a GPU instance. So we're going to do a p3.xlarge. Now, of course, you can go online and search for our EC2 instances in SageMaker and understand what is what. So there are some CPU-based training instances. There are some GPU-based training instances. For today, we'll be using MLP3 2xlarge. So we're going to be using one. We're not doing parallel processing. We're going to define our lab entry point. So we're going to be pointing to this folder. So the source directory uploads that entire directory up to the training job. So we're going to call it that. And then we have to tell it what is the entry file, which is because you might have a lot of different Python files, which is the job to kick off, which is your bootstrap script. So in here you'll see it'll be using this name, this file. Now, your model will, of course, output different metrics, and because you're bringing your own script, you can use regex to extract the output. So in the output of, when you're training your model, it might console log the output of the values. You can use regex to extract this information out as metric data for your training. And later on, when you do hyperparameter optimizations, you can use this to measure the performance. So we're going to define a couple of metrics that we're going to extract out of the training job. And then we're going to set some default hyperparameters, sort of default, for the model. So we're going to do some default epochs, number of cells, number of layers, dropout, 0.2. So just copy these values. And then here, we're going to be kicking off our training job. So we're going to import some of the standard stuff that we need, just in case. You can see some of the stuff we already imported above, so you might not need to import it again, but we just wrote it just in case. So from here, we imported sagemaker.mxnet, because we're going to be using an mxnet algorithm. So similar to earlier, the presentation, there was TensorFlow. This one's for mxnet, so we're importing that. We're going to get the execution role, which is the SageMaker's execution role that we define, that you define in SageMaker Studio. You, of course, can pass in other roles if you need to. When we create our mxnet estimator, we define our entry point, which was what we configured earlier, the folder, where our source, not the folder, the Python script name. We're going to define the source directory, what folder to upload to training, including the dependencies, things like that. Which Python version we're using, so we're using Python 3. We pass it the role so that if we don't pass this role, it's going to fail. It's not going to be able to run the job because it doesn't have permission to access your S3. It doesn't have permission to trigger a training job. It is very bare bones. So you have to pass it a role that has permission to do that. Then we tell it how many instances, because in some cases, especially if you're doing deep learning models, you can do a lot of distributed training, so running one model training across multiple GPU instances. So in this case, you might be able to create more instances to do the same process. But for today's purpose, we'll use one. We're going to use the GPU instance that we mentioned above. We're going to pass in the hyperparameters. Now, input mode, we set to file, but there's, I think, right now 2 major modes, file and pipe. File means that it will copy the entire file into the EBS volume before it starts training. It copies the whole file over. Pipe allows it to stream the files as it comes in. The benefit of piping allows you might have a large data set that you can't all fit inside an EBS volume, or you can't, or you don't want to have to spin up a huge volume just to be able to store that. So you might want to pipe in data, stream in data as it's training, so on demand. That allows it to start up faster, but that does require a specific format. You need to structure your data set specifically into a specific format that allows it to stream. I think protobuf or something. So for today's workshop, file. Now, of course, a lot of people are always worried about cost, which is very important. What happens if your model starts running too long? How do you terminate it? So you can specify a max runtime. So if it runs too long, terminate it. Another benefit is you can also do things like checkpoints. You can define checkpoints to be written out to S3. Specify our metric definitions and what framework we're using. Once we've done that, at the bottom, we'll call .fit. .fit is what triggers the training job. When we call the .fit, we give it the S3 location. So earlier above, we defined our S3 data URIs, where our input is. So that object will tell us where our training data set is, where our validation data set is, and SageMaker will then use those for training and then validating to get initial metrics. So we're going to run that. And that's kicked off a job. So you can see it's starting a training job. Now, if you want to see what's happening behind the scenes, you can, of course, go back into the SageMaker console. In the SageMaker console, you can see here we have a training folder, training section. Just zoom in. Training. So you can see training jobs here. So you can see this kicked off. When I kicked off a training, it actually shows up here. This is what the SageMaker SDK does. So earlier someone asked, well, how do we do it locally? What we did just now in the IDE, you don't have to do that in the IDE. If you do it locally, let's say you spin up a Jupyter server or a Jupyter Lab local instance, you run the same things. You might have to pass in specific roles, permissions, but when you do the same thing, SageMaker.fit, it still creates a training job here. So this is a distributed cluster of, or this is a managed cluster of training instances that you won't see. This is fully managed by SageMaker, and all you need to do is tell SageMaker, hey, I have this training job, or this model, or this algorithm, or this script that I want to train. Here's how to train it. Please train it for me. And SageMaker will then take that and train it for you behind the scenes with our own cluster, essentially, behind the scenes. And as you can see here, later on you'll see training time, billable time, and you can see it's in seconds. So as I said earlier, SageMaker training is billed in seconds, so you only pay for down to the second of what your training length is in seconds. Oop, this one failed. Is anyone having trouble launching a training job? I'm having trouble launching a training job. Oh, someone had a really good question. So when you're spinning up these Jupyter Lab notebooks, behind the scenes there's an EC2 instance. Now, there's a cost incurred here, and if you want to shut it off, it's actually quite easy. Over here, when you open this, you can see the number of running instances and what they're doing. So you can see I have a T3 medium Jupyter notebook, a G4DN, which is another GPU instance, which is what this one's currently using. If I want to shut this back down, I just go here and shut it down. And then it will shut down the notebook instances. So if you don't want to continue incurring costs afterwards, you can just shut these down here. And then when you open this notebook back up, if you select the same instance, it will spin it back up. And of course, all these files, as long as you save it, as long as you command save, when you write command save, it writes it to an Elastic Files EFS, our Elastic File Service. So essentially, behind the scenes of SageMaker Studio, there's a file server, a shared file server that everyone within the domain has access or can use, essentially. So when you save your files, it's persisted in this EFS volume. Meaning, if you shut these down, you're just shutting down the compute capacity. Your data is not lost as long as you save it. Because if you have changes that you haven't saved, then of course you'll lose it. It's like shutting down a computer. There are some people who are having issues. I'm also having issues. If you're having issues with training, might want to try X large instead. So change that to an X large. See if that will help it. Let's see if that will help. Oop, what did I do? Oh no, sorry. There's no X large. P3. See if we can get a P2. P2x large. So if you're currently having issues with the training with an instance, you might want to change to a different instance. I'm trying a p2.xlarge, see if that will help. So we'll see how that works. Okay, it seems like this one worked. So if I go back here, training jobs, I'll have a new training job here. So it's in progress. Let's see if this one works. So this will take a little bit of time to train because what's happening behind the scenes, as I said earlier, is that it's spinning up an instance behind the scenes, the requested instance that you wanted. It's copying our deep learning AMI, so our MXNet 1.6 Python 3 deep learning AMI, copying into the instance. It's copying your training data from S3 into EBS volume, configuring that up, bootstrapping the whole thing with the environment variables, kicking off the training job. So what it starts is it prepares the instance first, copies the files, and then triggers the training job in your Python script. Is everyone doing okay so far? Anyone need any help? All right. So basically the way our instance families work is that, or the naming convention, is that it starts with, let's say P2, P3. Those are our families, or the P, the letter is the family. So P is our GPU instances for deep learning training. 2, 3 is the generation. So we have P2 is our previous generation, P3 is our current generation, and then so forth. And then after that we have .xl, .2xl, things like that. Those are the sizes. Number of vCPUs, RAM, memory configuration. That's how we define our instances. So for today's workshop, we tried to do a P3.2x large. If that didn't work, we can always try a different instance, P2.x large as well. So that's using a previous generation of our GPU instances, just to make sure that we spread out capacity to everybody. So if anyone's having issues with running their training job, you might want to try ml.p2.x large. Okay. Is that okay? Okay, cool. Yes, because each configuration has, like each one's its own specific instance. So if let's say 2x large doesn't work, you can try a different size as well. Yes, there's 8x large, 16. I don't know if this account can launch that. You might have to submit a ticket to get. So when you open your account, there are some defaults that, or we call them service quotas. And in those service quotas, to prevent misuse, or we don't want, so we have had a lot of cases where customers have accidentally, had their keys stolen or something like that, and someone's just spun up a lot of instances. So we set guardrails called service quotas. So within the console, there's a section called service quotas. You can just raise that limit whenever you want, and that just is a fairly quick approval process. Is everyone doing okay with training their model? I'll give everybody a few more minutes because training these models do take time. Anyone stuck? Everyone okay? All right, let me see where my training's at. If not, I have another account to show everybody. Nope, mine is still running. But anyway, so you can see it outputs all the steps that's happening. So started the training job. It requested for that particular ML instance that I stated. Started preparing the training instance for training, downloading the container, setting that up. Then it started downloading the input data that I defined, downloaded the training image, and then started kicking off. So you see here, everything in here is should be outputted from the container. So this is everything that's happening inside, installing dependencies, setting up the training environments. So you can see here, it's using a particular framework, MX container. The channel where the training data is now placed in the container, you'll see it in this folder. So you see here, the instance we have has 4 vCPUs and 1 GPU. So this is all just configuration. It's just running for you. So this is all the gluon's output. And there's just going to be a bunch of information here. It's just going to keep running. It's going to keep training for a while. Oh, did that finish? Oh, yeah. So once it's done training, it's completed 100%. It starts uploading the generated model back to S3. So we should be able to see in here a new training job here. Is it this one? No. Yes. Not sure if it's this one or that one. So still writing it out. Oh, there we go. So the training job is completed, and we see once it's done, the training seconds took 400 seconds to train. So this was a quick one, 8 minutes or so, small data set. The billable seconds is 400. So the reason why we put those two is that we do have a capability called spot instances, which is leveraging excess capacity or not excess capacity, or maybe excess capacity in AWS for a discounted rate. So you can get up to 80% discount of the instance usage. However, the flip side is that if there's a demand in that instance, we may have to terminate. So we give you, I think, a 3-minute notice, or a few minutes notice, 4-minute notice period, before we shut down the instance. And so the reason why we do that is for a discount, greater discount. Basically, extra capacity, excess capacity can be used at a discount. In training, you might be wondering, oh, why would I do that? If it cancels it, then I lose everything. That's where checkpoints come in. So when you start your training job, you can specify a checkpoint, and it will start every time it reaches. It will start writing checkpoints out to the EBS volume. If it ever receives a shutdown notification, it will then write that checkpoint out to S3. And so when you resume your instance to continue training, you can continue where you left off on that checkpoint. So you don't have to start from scratch again. So that's a nice way to get some cost savings into your training. All right, so once we've done our training, what we're going to do is we're going to get the training job information, and we're going to pull the data back out. So it should be in S3 somewhere here. Is it in here? No. It's in one of these training jobs. There it is. So in here you can see that we had our source file, which is where what we uploaded, or what SageMaker copied into the training job. And then we have an output folder. The output folder is where the model is written. It's compressed, but it's written out into this directory. The output is extra stuff that our training script did. Our training script, if you look inside the training script, we also generated some graphs to visualize the output. So we also wrote that out. So anything you write inside that output directory gets placed into here. So it doesn't have to necessarily just be your models. You can, whatever you write out, you can do other processing stuff and then write it out. So what we're going to do is we're going to call the latest training job. So we're going to pull the latest training job that we ran with this estimator that we had earlier. We're going to get the output S3 output path. So you can configure where it outputs. So if you want to programmatically get that back, you can describe the training job. The training job will tell you where it is. So we're going to get that, and we're going to pull the artifacts in the model, or we're going to pull the output and the model folder or files out, and then unzip it. So once we unzip it, we place it into a model path. So if I refresh this, you'll see there's a model folder. Now in here is the actual model, the serialized model of your MXNet algorithm, right here. So a couple of different files, your parameters, your input transformation, your network weights, things like that. And then it also generated inside the artifacts, it generated 3 charts just for visualization. So we're just going to display that here. So you can see here that we took 3 different time series within the training data set and displayed them. This is all electrical usage data. And we're just gonna, we essentially just predicted the last 24 hours, I believe. Here you can see that the prediction generated different confidence scores, different levels. So based on different confidence scores, it gives you different ranges of values, P, P90, P10, P50, things like that. And then behind the blue line is the actual data set. So you can use this to compare the accuracy of your model, especially with the metrics. So you can see here a lot of the models do seem to align with the actual graph, with the actual usage. Now, usually after this, we start talking about hosting your model on AWS. We can go through that a bit later if we still have time. I think we do still have a bit of time. But I wanted to show you, if you were to containerize this yourself, how would you load this model? Let's say if you were using MXNet. So the next step, we'll load it locally within this notebook. So what we're going to do is we're going to import Gluon's model predictor. And then we're going to deserialize the model. So all you need to do is call predictor.deserialize, pass in the entire model folder. Once it's done, I can do the exact same thing that I did earlier. The main difference is that I will call this make evaluation prediction, which is a package in Gluon ts.evaluation, which is a function there. And then I'm going to pass in my predictor, my samples. I'm just going to pull out 100 samples. We're passing in our test data set to validate it. And then we're going to create a forecast with that information. So we're going to pull the historical data. We're going to take the same test data that we had above and then use the forecast to predict the next 24. So when we call that, you can see that this is generated locally. This I didn't need to run hosting elsewhere. So if you're containerizing your project for the purpose of the challenge, all you need to do is have a Python script that will deserialize your model right there. So essentially, you don't necessarily need to use SageMaker for everything. The benefits of SageMaker is that it's very, very modular. You use which part benefits you the most, you can just use. The rest, you can do it however you want. So you can just use SageMaker to offload your training, to do massive scale training and hyperparameter optimizations. And then when you're done, the model is in S3 for you to take out and use it however you wish. So this is essentially just how you load your model locally later on if you want to host it. However, if you want to use SageMaker to host an API if you're testing something, or if you want an API to test in the future, all you really need to do is take that model that you used, the estimator that you used that trained your model, and just call deploy. When you call deploy, all you need to do is specify what your initial instance count is, because one of the benefits of SageMaker hosting is that we can auto scale for you. So you can start off with one instance, and then based on maybe number of requests, you can automatically scale it out. So this we'll be deploying that into a C4X large instance, which is our compute optimized instances. We'll be creating one instance. So when you do this, what happens? Same thing as training. We take an inference optimized image, let's say for MXNet. Take your model, put it together, put it on a server, and then the endpoint is protected by our APIs, our SDK. So in order to call our SDK, or call this API, it's not a public API. You still need a access key to be able to call it. So you can protect it using our identity access management, which is the users, essentially. You're logging in as an IAM user. You can set permissions on who can call this API as well. And so if you look at the next step, we'll call predictor.predict. That behind the scenes is creating a request to the API server for you. You don't have to worry about spinning up or creating your own Flash server, setting up your API, adding access protection. All that is done for you. You just need to use our SDK and call predict. That's it. Simple as that. Another benefit of, maybe I should give everybody a bit of time. Before I go in, I'll give everybody a bit of time, but one of the last things that is really beneficial when you're leveraging the elasticity of the cloud is if any of you have done any model tuning, especially on a local machine, you'll find that it's very slow and very iterative. You test one hyperparameter depending on your compute capacity, essentially, or your GPU capacity on your computer, you might be only able to run one training job at a time. But because we have the elasticity of the cloud, you can scale out your training jobs. And so we also have automatic model tuning capabilities inside SageMaker. So it functions very similar to a training job, where you essentially tell it the hyperparameters, your model that you're using, or your algorithm that you're using, what container you're using, and calling the train or the fit function, or there's, I think it's a fit as well. However, the main difference for this is that earlier we defined some variables for our hyperparameters. The difference with this is that you, instead of specifying specific values, you can specify ranges that you want SageMaker to try. So in here, we can specify some integer parameters, so any integer between 12 and 70. We can specify continuous parameters, so any floating point between 0 and 0.5, so any decimal numbers between those two. We can specify different scaling logics to try at what intervals. And we can also specify what categorical parameters, so to try maybe binary categories, so true, false, essentially. And so when we do that, we can then tell it, oh, which metric am I trying to optimize for? So in this example, we're optimizing for the normalized root square error. And we specify how many maximum parallel jobs we can run. Because they can handle in distributed nature, you can specify parallel jobs to run faster. So you can run 2 jobs at a time, testing different combinations. Up to 10 jobs is what we, when we set maximum jobs. So in this example, we set 10. And then essentially, once we've set all that up, all we need to do is create a hyperparameter tuner, which is very similar to all our other estimators. And then we call the hyperparameter hpo.fit. Now, this will take a long time because you're running 10 training jobs, 2 at a time, which means you're running 5 cycles of training jobs. So it will take longer than your earlier training job. But I will show you here, once you've done that, you will have a hyperparameter training job here. So once you trigger a hyperparameter training job, you can see here, I've completed it. I've completed 10 jobs, none of them failed. Each one targets the same objective metric value, which is the NRMSE. I passed in the training configuration. It's the same as our training jobs, where I specify what algorithm, what training image. My tuning objective is NRMSE. I'm trying to minimize that value. So depending on what objective you're doing, you might want to maximize or minimize that value. And then once you're done with that, it will take all those training models or outputs and give you the best training result. So you can see here that out of the 10 training jobs, this one performed the best. And so from here, I can then see where I placed it out to. So here I see the output is somewhere down here. So the output path is my SageMaker bucket that I defaulted to. So I just need to look for this in my S3 in here. I just need to look for this. And this is my best performing model right here. So you can leverage SageMaker to not only train your jobs, but also tune your jobs or do hyperparameter tuning for you, where you no longer need to test out different optimization methods or different ways. You can just do that all in one go, and we'll handle the heavy lifting behind the scenes. So if everybody has, feel free to try and run the job. It might take a while. Deploying the predictor also takes some time. Oh, it's already predicted? Okay, so it's deployed. I'll jump back a little bit. So you can see here, inside inference, I have endpoints. And so in here, this is the endpoint that I just deployed just now. So in here, it's a real-time endpoint. SageMaker supports 3 different ones now. There were originally 2, but we just announced a new inference option. So the first one is real-time. So it has an instance running 24/7. You can call it whenever you want. The second use case is if you have batch mode. Let's say you have a bunch of files that you need to do it on a daily basis. Then you can do batch inference or batch transform. Batch transform basically spin up a job, tell the job to run inference on a specific location, ingest the files in that location, and output the results. And our newest option is serverless, where you pay for the number of invocations. So you don't need, so this use case is somewhere in between the two, where you might have some real-time needs, but you don't know when you need it. So you don't want to over-provision capacity. So you can use serverless offering to run on demand. So it becomes an invocation cost rather than a running cost. So this is where I've outputted the model, and then I can use this. So we have to tell it to how to serialize and deserialize the data. So we're going to pass in some CSV data, so we're going to serialize that. We're passing in JSON data, so we need to deserialize that, and then we're serializing back to CSV. So we take our data, and then we turn it into JSON, and then we tell our predictor it's going to deserialize, it's going to ingest JSON and deserialize that for us. And then it's going to output back CSV. So when we do that, we call predictor, that calls the API. That API returns the results. The results are now a Python object. And so here, we can then call it to see the predictions. These are now called on the server side. So these are the results pulled from the server side. And then once you're done, of course, you can just delete the endpoint when you don't need it. I'm not going to run that. And then if you want, you can try and run this. I don't know if we have time to finish it. So we're just going to specify a couple of different things. Our objective is NRMSE, I believe, yes. And then our epochs are 5. Our parallel down here, our max jobs are 10. And our parallel jobs are 2. So I call this, ignore, an error, whatever. I ran out of resources for here. So this is where I mentioned earlier that we have some service quotas that you need to raise potentially for protecting your resources. So you can see here that the quota for GPU instance was 1. So if we needed 2, we need to request. So if you need to, you can go here and go to service quotas. Should be here. So if we go into service quota, because this is a sandbox account, we aren't able to explicitly request. But essentially, you can go here and find SageMaker. Oh, I can't show it here. I'm going to show it here. So this one's my own account, so I can show you. Oh, is it not here? Oh, maybe it's in the SageMaker. If it's not there, then it's in support. So you can open up here, Support Center. Because if it's not there, it should be here. And then you can create a raise limit case, service limit. Then here, so we can do SageMaker, and then we can do training jobs. Oops. So we go here. You can request, let's say, we're in Singapore region, resource type, training, and then limit. I'm going to do P3 or P2.xlarge. And then I can request a new limit. So this is how you can raise your limits for SageMaker. These are just quotas. Essentially, they're just soft limits that protect your accounts from being abused. So in here, unfortunately, there's a limit. So I might have to set it as 1 parallel job at the same time. So if I trigger that, oh no, that also didn't work. Oh no, it did work. So when I do that, it's going to take even longer because it's parallel jobs 1, which means that it's running 1 training job at a time. However, in real world scenario, when you're not in a sandbox account, you can run it in parallel, more in parallel. So we have a little bit more time. See if everybody wants to just try and finish off the lab. If anyone has any questions, feel free to raise your hand. Maybe we can do a Q&A. Let me run over. the SageMaker SDK allows you to call to do the training on AWS or offload. What he was asking was, if you don't want to use this IDE and you want to do it on, let's say you have a local instance of yours, but you don't want to use, you still want to leverage the cloud perspective. You can take this and put it there as well. So essentially, this code, you put it down into your, you actually just open it up in a local directory. Yeah. The only major difference would be you have to configure your AWS SDK. You have to configure your credentials. So our SDKs. Let me explain to everybody. So the way our SDKs work in terms of credentials is that there's a hierarchy of how it pulls credentials. The first thing you'll look for is if you pass it explicitly into let's say you create a new instance of our SDK in Python. You can pass in our access key and secret key right in there. I don't really recommend that. If it's not there, then it will look for environment variables. So there's 2 environment variables that we define, I think AWS access key and caps _. After it looks for there, if it's not in the environment variable, it will look for a folder in your user directory, a .aws folder /credentials. So it'll look there. If you download and install our AWS CLI, you can type in the command line the AWS command. So you can type in AWS configure. When you type that, it's a helper to help you write your credentials into the AWS credentials. Maybe I can show you it to you for the example purposes. So someone asked if you want to do it offline, like if you don't want to use SageMaker Studio's IDE, if you want to use our local instance, let's say you have a local Jupyter notebook running, but you still want to leverage the training into SageMaker. Maybe you have a lot of extensions set up in your Jupyter Lab instance, but you still want to leverage AWS for training, you can use the same script. There's only one, off the top of my head, there's only one major change that you need to make sure, is that in the SageMaker Studio, we already set up your credentials for you. So the credentials are stored behind the scenes in something we call the instance metadata store, so it knows how to look for it. However, if you do it locally, you need to set up your credentials for AWS. So, what you need to do to help everybody, to make it easier, install our AWS CLI. So our command line interface tool allows you to call AWS, very small, AWS. So you can see you have an AWS CLI running locally. You can then call AWS configure. From here, it will ask you for an access key. Now, for an access key, you can go, if you have your own account, it depends on if you have a root account or an IAM. So when you register for an AWS account, you use an email address to register. That is called the root account, which is the primary account. However, you might want logins below that. And so that leverages something called IAM. It's a free service. Everything is built behind this. So inside IAM, either if you're the root user, you should be able to see your access keys in here somewhere. But my account right now is not root access. So you should be able to see root access somewhere. If not, if you're in IAM, you go to user, you can add user. So this gives you a new login to log into the console using this role, this user. You can see inside my user, I have security credentials. So I have enabled access keys. So you can create an access key here. When you create an access key, you get a pair. You get an access key ID, which is a public key, and you get a private secret key, which is displayed to you once. So be sure to save it, because if you delete it, you can always delete it and regenerate it. But once you have that, you can call AWS configure. So when I call AWS configure, it'll ask me for my access key, so I put that in. Secret key, I put that in. What my default region is, I don't know why it's EU West. So I'll just set AV Southeast. Output JSON. What this does is that it calls, oh, I don't know how to zoom this in. Can I zoom this in? Sorry, I don't really know if I can zoom this in. So if you go to your user credentials, your user folder, it's a little bit small, but this is my user folder. There'll be a .aws hidden folder. In there, there'll be credentials. I'm not going to open this because security. I have my secret keys in there, but in here is essentially the configuration for all my account secret keys. So with that, I'll be able to call. List out all my S3 directories, things like that. So this is essentially a tool that I can use to access as AWS. However, the reason why we do this is because this is where the SDK also looks for. So as I said earlier, the SDK has a hierarchy of places it will look for the credentials. If it's not directly written into the file, is it environment variable? If it's not, is it in our instance metadata store? This is for AWS specific instances. If it's not there, is it in a .aws folder? And so, if I go back to here, everything else should essentially work. Because when I include all this, earlier, all the SageMaker stuff. I don't know where it went. Here, when I call Bodo3 and SageMaker, it should be pulling from that location. So it should be generating based on, as long as you set up your credentials in your local file, in your local user folder, you can take this script and you should be able to run it locally as well. Because there's nothing, all this is an interface to our SageMaker API. So you're essentially taking this and telling SageMaker to do the training job. And so you're passing this on to SageMaker. You don't have to use our IDE if you don't want to. Does that answer your question? Okay, cool. Does anyone else have any questions? I think we have a few more minutes for Q&A if anybody has any questions. Everybody okay? All right, so I have I have a slide, I think 3 more slides to just show real quick. So I know this was very short, and hopefully everybody can learn something from this. Usually these are a bit longer for our workshops because machine learning is a very complex and long topic. So hopefully with this, everybody can get a little bit of a taste on how AWS handles machine learning. So I have a few resources here for everybody. If you're interested in a bit more Gluon time series, you can go to ts.gluon.ai. If you're building your own model, or building your own container, which for the purpose of the workshop or for the competition might be a bit too much. But of course, if you want to understand how our deep learning AMIs work, you can look at our SageMaker training toolkit. But the most important part is looking at our SageMaker deep learning containers. See which which frameworks we already support by default, because that way you can get started much faster. For students, I think we have a little bit of introduction. For students, we have a program called AWS Academy. You can register. Is there a registration there? Yeah, there's a very small link, AWS Training, AWS Academy. So essentially, AWS Academy is a free resource for students. If you're interested in learning more about cloud, we have a lot of free resources on the platform for students to learn about AWS. There's a lot of Cloud Foundation and Machine Learning Foundation exercises. There's a lot of labs. There's also, I believe, credits. There's a lab environment that you can use an AWS account that has some credits for you to use. There's also discounts on the exam vouchers if you want to take the AWS certifications. So for students, feel free to register for AWS Academy. For startups, we also have another program called the AWS Activate program. So the AWS Activate program offers tools, resources for startups to quickly get started on AWS. With that includes Activate credits, credits for you to consume. So if you use our founders tier, you can get up to $1,000, I think, in AWS Activate credits. You also can get some credits for our support plan. So there's a few requirements for eligibility. So if you're a startup less than 10 years old, you have an AWS account, which is kind of important, and you haven't received previous funding from the Activate program, then you can get our founder tier. And then our build and grow tier are essentially if you're a startup that is part of an accelerator, incubator, or VC program, you can get essentially more top-up credits for your business to run over, I can't remember how many years. But you can also get business support credits for that. So we have two programs for startups and for students. Feel free to, I think we'll send this out later to everybody, I think, I don't know. I'll work with everybody to see if I can send these slides out. So with that, thank you very much for everybody's time. Hopefully we all learned something today, and feel free to, I think, reach out if you have any questions. Thank you very much, everybody.